Now we can do a question that most people got wrong when they took it on an official GRE test. We're told the average arithmetic mean of 100 measurements is 23, and the average of 50 additional measurements is 27. And we're asked to compare two quantities. Quantity A is the average of 150 measurements, and quantity B is 25. Well, some people looked and they saw they had 100 measurements and they didn't know what any of them were, and they had 50 additional measurements and they didn't know what any of these were, and so they didn't know the average of the 150 measurements, and so they said, I honestly don't think the relationship can be determined from the information given. But more people actually looked at 23 and 27, and they looked at 25 in column B and they said, well, gee, they've got an average in quantity A, and quantity B is 25, and the average of 23 and 27 is 25, so we think that the average is equal in both quantities, and C is the answer. The two quantities are equal. But this is actually a weighted average. It's weighted with 100 measurements at 23 and only 50 measurements at 27, so the average of the 150 measurements is weighted in one direction. We can figure out why by doing the problem the old-fashioned way. The average of 100 measurements is an average of 23, so that's the total divided by 100 equals 23, so the total equals 2300. Now we have the average of 50 measurements, which is 27, so that's the total divided by 50 equals 27, so the total equals 1350. Now we're ready to figure out the average of the 150 measurements. That's the total, which is 2300 plus 1350 over 150. Which means that's 3650 divided by 150, which means our average for the 150 measurements is 24.3333. It's a repeating decimal. Now we're ready to compare the two quantities. Quantity A is 24.333 and quantity B is 25. Which quantity is larger? The answer is B. Here's an easy way to visualize a weighted average. First of all, imagine what a perfect average would be. You could have 23 and 27, and the average would be 25. Now let's see what happens if we just had 10 measurements at 23, 5 measurements, and 27. How could we compare these two? Well, we could put 10 23s on one side and 5 27s on the other side, and can't you see that the average is weighted toward the 23s? Each of one of those 23s is 2 less than the average, and each one of the 27s is 2 more than the average. If we wipe out 5 on each side, we've still got 5 left over that are each 2 less than the average. And so as we try to balance things out by moving a 2 from the left over to the right, we have to move the average down toward the left. And as we do this here, we end up all the way over to 24.33. But that's if we do exact math. We only have to do comparative math. And once we realize the average is weighted below the 25, then we already know that the answer is quantity B is larger because 25 is the average if it was a pure average, but this is weighted towards the lower end. Testing for the public. Nonprofit since 1985. No one makes things easier.